This video covers exponent rules, and our instructions in this video are to simplify the following exponential expressions using positive exponents only. So we're going to start with 2 to the 4th power. And to work this out, to start, I'm just going to demonstrate expanding an exponential expression. So to expand it, you're doing 2 times 2 times 2 times 2. So 2 to the 4th power is just multiplying 2 by itself 4 times. 2 times 2 is 4. Times 2 is 8, times 2 is 16. So 2 to the 4th power is just 16. The next one has a negative out front. So that negative is not being raised to the 4th power. It can just stay out front. And then you would have 4 2's multiplied together after that. So just like the previous one, 2 times 2 is 4, times 2 is 8, times 2 is 16. But we have the negative in front, so it's going to be a negative 16. The difference with our next one is the full negative 2 is being raised to the 4th power. And that means negative 2 is being multiplied together 4 times. So it's not like a negative stays out front and the 2 gets multiplied 4 times. The whole thing gets multiplied by 4 times. And this is going to be a little different than our previous one because negative 2 times negative 2 is positive 4 times negative 2 is negative 8 times negative 2 is positive 16. So it does make a difference whether you include the negative or don't include the negative. So keep in mind what is being raised to the power, and if the negative is not being included, then do not include it when you're trying to multiply it together. The next one has 2 x's multiplied together, then 3 y's multiplied together. There is just one singular x there, and then 2 more y's. Some people think that this means there's 2 x's there. It doesn't. There's an invisible 1 on that x that you can't see, meaning that there is only one x there. I'm just going to combine all of my x's together. So I'll say I have 1, 2, 3 x's multiplied together. So I'll have x to the 3rd power. And then I have 1, 2, 3, 4, 5 y's multiplied together, and I'll have y to the 5th power. Okay, next we have a mix of numbers and letters. So I have a singular 2, 4 x's, 1 5, then 3 more x's. My 2 and 5 can get multiplied together just like normal, and 2 times 5 is 10. And then I have 1, 2, 3, 4, 5, 6, 7 x's multiplied together. So I'll have x to the 7th power. Next, I'll have 2 with 2 x's, and then I have 2 3's multiplied together, and then 2 more x's multiplied together. So 2 times 3 is 6, times 3 is 18. So that's all of the numbers multiplied together. And then I have 1, 2, 3, 4 x's, so I have x to the 4th power. Here, you'll notice this looks really similar to this. So we want to make sure to leave that negative out front when we raise it to the power. I'm going to rewrite this as a negative 2 squared, and then I'm going to distribute this 2 to my 2 exponents here. So whenever you see an exponent raised to another exponent, you're just multiplying those exponents together, and you can almost distribute just like, using the distributive property. It's really similar to that. So we have a 1 on our 3, and 2 times 1 is 2. So I'll have 3 to the 2nd power. And then we have a 3 on our x, and 2 times 3 is 6. So I'll say x to the 6th power. Now I can work this out. I'm going to have negative 2 times 2. So remember, the negative is not included. It's just hanging out front. Times 3 times x to the 6th. Negative 2 times 2 gives us negative 4. Times 3 gives us negative 12. Times 3 gives us negative 36. So we'll have negative 36 x to the 6th power. Now we have some exponents that are in division, or some people might consider this a fraction format. Let's go ahead and see what happens here. I'm going to expand my first exponential expression by having 1, 2, 3, 4 3's on top and 1 3 on the bottom. You may recall anything on top of itself, like 3 over 3, it just equals 1. So what we're going to do is when we see anything that matches one on top of the other, we're just going to go ahead and cancel them out. And we don't need to write down 1 here because 1 times anything is just what it is. So the 1 is extra and it doesn't need to be included. So in this case, we're just going to have 3 times 3, which is 9, times 3, which is 27. So this will be a positive 27. Next, we have 7 x's on top. So 1, 2, 3, 4, 5, 6, 7 x's on top. And then 1, 2, 3, 4 x's on the bottom. So anything that matches on the top and the bottom cancels out. And then we're left with 3 x's on top. So we're going to have x to the third. And if you have something just left on top, there's no need to put anything underneath it because a number by itself doesn't need anything underneath it. And an x to the third by itself doesn't need anything underneath it, okay? Next, we're going to have 24x cubed over 6x. And I'm not going to write this one fully out. I think we can do it just by talking it through. We can divide 24 by 6. 6 goes into 24 a total of 4 times. Then we have 3 x's on top and 1 x on the bottom. So imagine we wrote that out. The 1 x on the bottom would cancel with one of the 3 x's on top, and you'd be left with just 2 x's on top. So it'll be 4x squared. I am going to write this one out just so we can see it. It's 1, 2, 3, 4, 5 4s on top, and then 5 4s on the bottom. And what will happen here is that anything on top of itself will just cancel. And you might be thinking, well, there's nothing there. Do we recall that anything on top of itself is just 1? And the reason we don't write anything down is because 1 times anything doesn't do anything. But if there's nothing there, that 1 is still important. We need to say 1 would be the number there. Because we're not multiplying it by anything, we can't just make it go away. So 1 is the answer anytime you see anything on top of itself. Next, we have 3x to the fourth y squared over 9x to the fourth y. The first thing I'm going to do is reduce my numbers into a more simple fraction. So right now I have 3 over 9, and I can put 3 into 3 one time, and then 3 into 9 3 times. Then I have x to the fourth over x to the fourth. And just like we talked about, all of those will cancel because of the x to the fourth on top will cancel with all 4 of those x's on the bottom. Next, I have 2 y's on top and 1 y on the bottom. So what will happen is my 1 y on the bottom will cancel with one of the 2 y's on top, leaving me with a single y on top. And you may want to put a 1 next to your y, but even if we have a 1 for an exponent, it's extra. You don't need to write it. So we want to leave it bare because if it's just a single y, there's an invisible 1 exponent there because we have just one singular y. All right, let's move on to the next one. We have -2 over 24. So we can reduce this fraction. 2 goes into both of those numbers because they're even. So instead of -2, we could do -1, and instead of 24, we could do 12. And that is just me simplifying the fraction that I have. Next, I have 4 x's on top and 2 x's on the bottom. The 2 on the bottom are going to cancel with 2 of the 4 x's I have on top, and I'm going to be left with 2 x's on top. You may notice that the 4 and the 2 just subtract, and I'm left with 2 on top, which is the bigger amount to begin with. Next, I have y squared over y squared, and those two will just cancel out, and nothing will happen. And then finally, I have z to the 5th power over z to the 4th power. And the 4 z's on the bottom will cancel with 4 of the 5 z's from the top, leaving us with just a single z on top. And again, you don't have to put the 1 on it since it's just extra. Next, we have some negative exponents. And negative exponents are just telling us if we had a fraction, the things that are negative in the numerator or on top, they're supposed to be on the bottom. And the things that are negative in the denominator on the bottom are supposed to be on the top. So a negative exponent just means it was put in the wrong place and it either needs to move down if it's on top or up if it's on the bottom. So this one is technically on top and that 2 doesn't want to be there. So we're going to push it down to the bottom. And the placeholder on top, if you have nothing, is always going to be 1. When we push it to the bottom, the exponent on our number becomes positive. So this becomes a positive 1 on our 2. The 1, like we have talked about, is extra and unnecessary, so we can just leave it as a 1/2. We don't need to put the 1 on the 2. All right, next, this 3 has an invisible 1 on it that we can't see. The 3 is perfectly fine where it is. We don't need to move it, so we're going to leave it on top. But those 2 m's don't want to be there, so we're going to move them to the bottom. And once they're moved to the bottom, they become positive. The 7 W's are perfectly fine on top where they are. The 9 W's don't want to be on top. They want to be on the bottom. So when we put them on the bottom, they become positive. Now, if I have 7 W's on top and 9 W's on the bottom, 7 W's will cancel out and I'll be left with 2 W's on the bottom. And again, just to reiterate, the placeholder when there is nothing on top is a 1. So this is going to be 1 over W squared. Next, I have 2 x's on top, so I'll actually draw this one out over 5 x's on the bottom. My 2 x's on top will cancel with 2 of the 5 on the bottom, leaving me with 3 x's on the bottom, and again, I'll need the 1 as the placeholder on the top. I'm going to have to distribute this -2 into both of the exponents inside of my parentheses. There is an invisible 1 on my 8 that I need to distribute to. So my -2 is going to multiply by my 8, and it's going to multiply by my 5. So I'll have 8 to the -2nd power and p to the -10th power. Both of those exponents are telling me that those numbers are in the wrong place. Right now they're on the top, so I need to push them to the bottom. So I'm going to use a placeholder of 1 and put my x squared and my p to the 10th on the bottom. And again, once they're where they're supposed to be, they become positive with the exponents. My final step is actually to do 8 squared, which is 8 times 8, and 8 times 8 is 64. So I'm going to have 1 over 64 p to the 10th. All right, last one here. We have 3 y's on top. They are just fine where they are. These 5 y's don't want to be on the bottom. We need to push them to the top. But we already have 3 y's on top. So those 3 y's get 5 more y's. So our 3 y's plus our 5 y's give us a total of 8 y's on top. And since there's nothing on the bottom, we can just leave it as y to the 8th. All right, our last 3 problems are going to be kind of complicated. So try to work with me here. I know they look complex because we're mixing raising a power to a power, and we're mixing fractions, and we're mixing some negatives in there. But I think you all have got this. There's an invisible 1 on this 3. The 4 that's outside needs to apply to all of the exponents inside of the parentheses. So every single one of them. Let's go ahead and start multiplying the 4 into my exponents in my parentheses. This 4 is going to multiply by this 1, giving me 3 to the 4th power. The 4 is going to multiply by the 5, giving me x to the 20th power, by the 3, giving me x to the 12th power. But I'm not done. I also have to apply the 4 to my 2 powers in the denominator. So this is going to be x to the 12th power on the bottom, and then y to the 24th power on the bottom. All right, let's simplify this even further. We have 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. So 3 to the 4th power is 81. I have 20 x's on top and 12 x's on the bottom. 12 of them will cancel out, leaving me with 8 remaining on the top. I have 12 y's on the top and 24 y's on the bottom. 12 of them will cancel out, leaving me with 12 y's on the bottom. And that's it. This looks pretty intimidating, but I'm going to teach you something really important. Anytime you see anything at all raised to the 0 power, the answer is just 1. So the numerator here is just 1. Our denominator stays the same. It's going to be 12, 8 to the 7th b. But seriously, like, it can be the most complicated thing you've ever seen. You could have 1 million to the 400th power times x to the 27th, y to the 312 over negative 18 to the 64th power plus z to the 14th power and q to the negative 3rd power. All of that raised to the 0 power. It's just 1. That's just 1. So anytime you see something raised to a 0 power, you go, hallelujah, I don't have to do anything crazy. It's just 1. All right. Let's look at our final problem here. There is an invisible 1 on that 4. And that's important to note because we're going to distribute the 3 to all of our exponents. So the 3 is going to go to the 1, to the -1, to the 5, and to the 0. 3 times 1 is going to be 3, so we're going to have 4 to the 3rd power. 3 times -1 is -3, so you'll have 8 to the -3rd. 3 times 5 is 15, so b to the 15th, and 3 times 0 is 0, so you'll have c to the 0 power. 4 to the 3rd we can work out. 4 times 4 is 16, times 4 is 64. Those 3 a's need to go to the bottom, so once they're on the bottom, the exponent becomes positive. Those 15 b's are perfectly happy on the top. Just as a reminder, anything to the 0 power is just 1. We do not need to write times 1 on the top here because multiplying by 1 doesn't do anything. So it's just extraneous to put it on there. Leave it off. We are just going to have 64 b to the 15th over a to the 3rd.